Well, that's a lesson learned. I didn't know that my recorder would cut me off at an hour. I normally don't make this long of a video, but this is kind of in-depth, so I'm sorry. Stinking recorder cut me off. So here we are. We're almost done, I promise, with this lesson. Okay, so the normal default on plot 1 is if you go in and you look at it, it's actually normally off. So let me click on this. Normally it would be off, and that would be highlighted, but I turned it on, so now the on is highlighted. The normal default is for it to give me a scatter plot, which is kind of what I want, and for it to be in the list 1 and the list 2, and sometimes it'll be the little bitty dot that is, can y'all see that? It's kind of got a glare. Sometimes it's this little bitty dot that is what it defaults to, but I like the squares or the pluses, either one. So at any rate, what I can do is I can, once that thing's turned on, go back to my y equals. We see the formula, we see that plot 1 is on, and what the calculator should be doing, sorry, I'm trying to find a spot with no glare. What the calculator should be doing is it should plot the scatter plot from my data points that are in my L1, and it should plot this, which is what it thinks is the quadratic regression. So here we go. There are my scatter plots, and there is the quadratic regression. And of course, it's hitting really nicely, right? Because there wasn't really any error on those points. If you've been in a 361, 362 class, one more time, sorry, I don't mean to say that again, but if you've been in there, you've probably seen where maybe some of your data points aren't exact and they're up and down, and so you have to make a little bit of compensation. But these were exact, so we got a really nice plot on it. Okay, if it worked out the same way, let me get back out here since I zoomed so far. Hopefully, yep, focus, good. Okay, if it worked out similarly with an exponential formula, we're going to do one of those and then we'll be done. Then we would know that, hey, we'll see some stuff going on in there. Example 2, we'll see some stuff going on there. I really want you to see an exponential before you have the homework to do. And I'll say, hey, what the heck's going on? Oh, I know that's an exponential, and then we'll show how to do that on the calculator, okay? So x's and y's, very similar to what we had earlier. This particular formula, or numbers, is going to be 1, 2, 3, 4, and 5. And over here I'm going to have 2, 8, 26, 80, and 242. So one of the normal giveaways that something might be exponential is that you see it either starts getting really super huge, which means it's exponential growth, or you start seeing really tiny fractions or decimals, which means it's exponential decay. So I'm thinking this is an exponential growth. Really just mainly because it just got so stinking big so fast, right? It went from 2 to within 5 terms, it's at almost 250. So stuff's going on. But if you're not sure, you can always look in here and you can say, hey, what are the differences? That's a 6. That's a, I already did this, so I'm not going to do it again. But you can use your calculator and check me. That's an 18. That's a 54. And that's 162. Well, clearly that's not a constant ratio or a constant difference, and clearly I'm not getting a pattern out of that. You might see something, but I sure don't. Okay, so I can do it again. I can look in here and say that's a 12. That's a, I don't know what that was, because I didn't write that down because I knew it wasn't. But anyway, I can see those, and I can see in the third differences. So I know this is not linear. You can double check me and make sure it's not quadratic and make sure it's not cubic. Okay, so check the second differences and the third differences and see what they are. I just didn't write them down because I knew what it was. So, but you can certainly check those and make sure and then tell me it's not linear, it's not quadratic, it's not cubic. So I'm going to check for exponential. What I would like for you to do with that whenever that happens. Okay, check. for exponential. And the way you do that is that you're looking to see if instead of a constant difference in here, there's a constant ratio, a constant thing that they're multiplying by. Remember last week we called that a geometric sequence, right? So 2, 8, 26. Oh man. 2, 8, 26. Oh, I'm sorry. Inside of the first differences. So you got to be in the rate of change, right? So I'm like, that doesn't make sense. All right, so I'm looking inside of the differences, not inside of the numbers, because I'm going, that's not anything that can add. So what's going on here? From 6 to 18, that's not a difference. Instead, it's a multiply by 3, right? 18 to 54. Look at that again. What did I do? I'm not adding. I'm multiplying 18 times 3, right? And 54 to 162, if you're not sure, divide 162 divided by 54, and sure enough, it's times 3. Okay, so there we go, times 3. All right, so I'm seeing, hey, I've got something going on in there, and I see a constant difference, or a constant ratio going on inside of my rates of change, right? So I'm just making sure I said it right last time. Yeah, rate of change is being multiplied by a number, and I did say that. Okay, so inside of there, it's being multiplied by a number, and so I've got exponential, and in fact, this number here that's being multiplied over and over and over again, we saw that last week in the geometric, right? There's some number times 3 times 3 times 3 times 3, right? So what's the number that's being multiplied by 3 initially? Yeah, it's a 2, right? So we're sitting here going, okay, I got some stuff going on in here. I need to make sure how exactly this is going to look. And it's not going to look quite like the geometric because it's not quite exactly like the geometric. It's an exponential function. So remember that there could be something multiplied out in front, or it could be just the bases, or it could be that I have the base raised to some power, and then once I figure it out and mess around with it, I can make it look in other ways. So sometimes you'll see both of those things happening. So again, I'm going to do what we did a minute ago. I'm going into Stat. I'm going to edit my lists. I'm going to stay in L1 and L2 because everything defaults to L1 and L2, and that's nice. But I'm going to have to change them. 1, 2, 3, 4, 5. And then over here at the top was 2, 8, 26, 80, and 242. And whenever I overwrite a list, I do try to kind of look at it and make sure that I type them in properly and nothing weird is going on there. And it looks okay to me. So I'm going back into Stat. I'm going over to Calculate on to the right. And we know that we checked it. We see it's times 3 in there, right? That this is going to be exponential. That is the number 10 on mine. Okay, if you don't have 10 or you don't have one of these, it might be something slightly different. Exponential regression, and you'll see it works pretty much the same way. L1, L2, and then I want to store it in the Y1 so that it automatically does it for me. And so I go into vars and then Y vars, functions, Y1, and I tell it that's where I want it to be. And then I ask it, please calculate that for me. So it's actually saying, hey, your base isn't quite 3, and that's because it's making a slight little calculation for me. That's all right. And he's saying y equals a times b to the x. So he doesn't have that plus h. That's why I said sometimes it'll be slightly different. And that's y equals, and they've got the b as 0.68, and the a is 0.68, and the b is 3.2, I'm just going to round 9, and it's raised to the x. So you can tell that's not quite in the same format of what I had a little bit ago, which was 2 times b to the x plus h plus the k. So it's going to look a little bit different than what we had. But that's okay because it's still an exponential function and it still should be okay. If I look at my y equals, then I can see it there. I still have the plot 1 turned on also. I'm going to have a little bit of an issue here though, if you didn't notice. This really shot up, right? And last time I only had the window that was in the 10 to 10, the normal standard, negative 10 to positive 10. So I kind of want to increase my y. So I can leave the -10, that's fine, but I'm going to shoot it up to 250. And I'm going to tell it, instead of counting by ones, the x or the y scale there, I'm going to tell it to count by 20s because that's pretty big jump. So now I'm going to ask it to graph. There are my dots, my points, and here comes its exponential regression, which again fits really nicely. So I like it, and it's all good. Is everybody okay? All right. Some quick notices about this. I said I would mention the other operating system. If your operating system doesn't automatically come up and say, hey, here's exponential regression, hey, whatever, and instead it says, it like pops up and you did the exponential regression. I didn't bring that calculator with me, but it brings you to kind of a blank page that just says exponential regression, and it doesn't give you all that other stuff. You can tell it L1, comma, L2, comma, Y1, and that'll tell it, hey, pull my list. This is my X value. This is my Y value, and this is where I want it to store it. So that's what that does in the earlier operating systems on TI-83s and 84s. So that's how you would do that. And in order to do that, you would again use the alphabetic keys down here, where L1 is right above the 1. So if I want that to work, I hit the second button up there and the 1, and see the L1 shows up. The comma is right above the 7, so like that. And then second and the 2 will give me the L2. So you could manually enter it that way. If you have the older operating system and you don't care if it saves it into the Y1, then you can just tell it exponential regression and then hit enter. Exponential regression and enter. And that just automatically uses L1 and L2, but it will not. So it'll calculate it and it'll spit it out right there on the main screen just like mine did, but it will not save it into the Y1. Okay, so this is like a real class period long because it's right at an hour and 12 minutes. So I'm going to say goodbye. There will be a housekeeping video with your homework, and thanks for sticking it out with me, guys. This was a really long one, but it's going to be worth it because I think day 2 should be shorter. Yay.